All right, so we've talked about lenses. And again, a lens is something, it's just glass, you know, transparent glass, and light goes through the lens. Well, now we're going to talk about something different, but related. Now we're going to talk about mirrors. So, of course, mirrors, the light reflects. Now, you're going to love it. It's very similar, you know, to what we've done in the past. So it's going to be very, very nice. Okay, so again, we're saying that the object is far away, and we're always going to say that, right? So we have these parallel rays coming in, and then they reflect off the mirror, and this is what happens for this type of mirror. Okay, so what kind of mirror is this? It's a concave mirror. And again, just like I said earlier, right? If you're out here, doesn't this appear to be a cave? Yeah, it does, right? A cave, okay? So it's concave. And again, this is the focal point. Rays converge at this point. No kidding, just what we had before. So it's wonderful. That's why you have to understand lenses first before you can hope to understand mirrors. Okay, let's do okay, so if this is concave, let's do convex. Okay, here's convex. Oh gosh, right? So here's the object. This is convex. It's certainly not a cave, right? It's convex. So you have the incoming rays, parallel rays, and then they diverge, right? So now the focal, okay, look, hold it. Here, for concave, the focal point was over here, right? And it's real light, agree? Real light, because it's reflected light. But here, you know, come on. Here's the outgoing rays, this guy, this one, this one, this one. They don't converge anymore. They don't intersect anywhere, right? So if they don't intersect anywhere to make the image, or the focal point, you got to backtrack. Okay, so this is now the focal point. Rays appear to diverge from this point. Yeah, that makes good sense. All right, now, it's very similar to lenses, right? You know, you buy a mirror with a certain focal length. You know how far the object is from the mirror. So what you want to figure out, just like before, is where the image is located and the magnification. That's all. Yeah, convex. All right, now look. There are 4 rays. So all you really need are 2, but I would recommend you do a third just as a check. And you just pick the ones you like. And I mean, it's awesome. And look, this one is totally terrific. All right, well, hold it. So we're going to assume that this is a sphere, right? Spherical mirrors. So this is a nice arc. So this is the center of the sphere. So in other words, this is the radius. So here's one ray. You just start at the center of the circle. You go to the mirror and back. Ha! Can't beat that. Here's another easy one. So here's the object. You just go to the center here and back. So this angle here equals that angle. That's pretty nice. But look at these other ones. Look. Parallel in, guess what? Focal out. But now it's reflected, right? And look at this one. Focal in, parallel out. So you see all the similarities? There's all these similarities. It's wonderful. This is totally awesome. Okay, so, all right, so that's for concave. Ugh, this is a bit more, so this is kind of, this is the tough one, all right? Not so bad, but kind of tough. So this is convex. Again, there are 4 rays, but it's kind of a mess. All right, but it's not so bad. Okay, here you go. Here's the object. Look. Parallel in. Now, you know it's going to diverge, so it goes out. But look at focal out, right? So parallel in, focal out. So that's similar. All right. How about this one? Okay, look at, there's parallel in, focal out. Well, shouldn't there be focal in, parallel out? Yeah, let's do that. Okay, oh, they don't really show it, oh, gee. Okay, so this one, look at this one here. So this one's aimed at the focal point, right? So focal in, and then, but it's a mirror, right? It's a mirror. So this one is aimed at the focal point, right? And then parallel out. Okay, so we have that one. Here's the nice one. It just goes through the center of the sphere, and then it reflects, right? So you know, but it reflects from the mirror. So there's 3. And 4 is kind of nice too, actually. You know, it just goes here, here. So it doesn't really look so great on this visual on the slide, but that angle is supposed to be that angle. All right? So, you know, I mean, it's similar to this, don't you think? Parallel in, focal out, focal in, parallel out, through the center, and then just right here, right? That equals that. But I mean, you got to kind of spend some time staring at this, especially this one, right? So this is focal in, but then it reflects from the mirror, so parallel out. That's why it says this is 2 and this is 2, right? Focal in, but parallel out because it reflects. So that's kind of a challenging one. You're going to spend some more time on that one, I admit it. Okay. Oh, my goodness. Oh, look at this. The same formula. All right? But there's something new. You know, so now this is the radius of the spherical mirror. So the focal length is equal to r divided by 2. And then you get another table you're going to deal with. Sorry. What can I say, right? What can I say? Okay, so let's just do it, huh? All right. Okay, so an object is 40 centimeters in front of a concave mirror, focal length 20. Use ray tracing. All right. So 40 centimeters. So the object, so S is 40, focal length 20. Okay, so in my opinion, I mean, it seems to work well. I actually used a compass to make these. This was supposed to be a real arc of a real circle, you know. But if you don't have a compass, just get a lid from a jar or something like that. It just makes it just works out well, you know. All right, so let's see. I had it up there, whatever. Okay, so here's the mirror, right? Concave mirror, agree? An object is in front of a concave mirror. So there's your mirror. The object's in front of it somewhere. Okay, so let's see. So focal length 20 in front, right? So there's your 20. Object is 40 right here. So there's your object. Don't look at this yet, right? Just look at object here, focal here. So here you go. Let's do it. Parallel in, reflect, focal out. Focal in, parallel out. We're done. Let's just do another one. Do an easy one. Just go from here to this point on the opposite axis and have that. Again, this angle equals that angle. Okay? I didn't do the third one. Oh golly. What? One moment, please.